The appearance of motion depends on frame rate. Here we show a moving bar at 24 frames per second. Effects like motion blur, temporal flickering, double edges, and motion jerkiness can be observed. When exactly the same bar is shown in 48 frames per second, the visibility of these effects is smaller. Depending on the frame rate, the appearance of real video footage is also changed. Here we show a sequence at 24 frames per second, and here the same sequence at 48 frames per second. Artists have very sparse set of choices, for example 24 or 48 frames per second. Despite the big visual difference between them, knowing between frame rates are technically possible. To overcome this problem, we propose a technique for emulating continuously varying display frame rates. Let us consider 1D temporal signal. If we want to display it on the screen, we have to convolve it with temporally shifted filter. Here we have a rectangular filter which mimics a standard camera. If the sampling rate is equal to the display frame rate, sampled frames can be directly shown on the screen. To display a lower frame rate, let us say half of the original display frame rate. We can halve the original sampling rate. To display these frames, we have to repeat every frame. In this case, the resulting frame rate is a perfect emulation of desired frame rate. To display other in-between frame rates, the standard solution is to follow the same procedure and further alter the sampling rate. However, whenever sampling rate does not match the display rate, some frames need to be repeated. This leads to significant artifacts as new, low temporal frequencies are introduced. To avoid these problems, our technique does not change the number of samples drawn from the original signal, but instead performs a non-uniform sampling. To this end, we introduce a technique that interpolates different frame rates by changing position of the sampling kernels. This solution does not involve repeating frames, which in the previous solution introduces artifacts. Not only sampling positions can be changed, but also the spatial support of filters can be alternated to simulate different shutter speeds. Here we compare a moving bar with interpolated frame rate using standard and our technique. Please note the low frequency stagger in the standard solution. The standard solution is also not suitable for interpolating frames spatially. Clear discontinuities on frame rate boundaries can be observed. In contrast, our technique enables continuous frame rate changes without visible artifacts. Here we present our results for interpolating between 24 and 48 frames per second. Changing frame rate continuously over time and space enables new content manipulations that were previously impossible. For example, the frame rate can be adjusted according to the local motion flow of information. Here, regions exhibiting larger motion are shown in a higher frame rate. Our technique can also be used to change the appearance of the video according to artist's intent. Here, the character is shown in a different frame rate than the background. Thank you.